number 1, name the vertex of angle 4. So angle 4, this angle right here, where its two sides meet, is at point U, and that is its vertex. And number 3, what is another name for angle 2? So angle 2 would be this angle, and its vertex is Y. So we need 2 other points to name it. We can name it XYU or UYX. Make sure that Y is the middle point. On number 5, copy the diagram shown and extend each ray. Classify each angle as right, 90 degrees, acute, between 0 and 90, or obtuse, between 90 and 180. Then use a protractor to measure the angle to the nearest degree. So I'm just going to look at the angles here and give you an idea of what to do. So on number 5, angle CFD, this angle is obviously less than our right angle. Okay, it's open up less than 90 degrees. Okay, so that would be an acute angle. And a good approximation for it on a protractor would be, I would say, about 40 degrees would be good. On number 7, angle BFC. So BFC, well, we don't even need to measure it because we have the box right there, which tells us that it is a right angle. Which means that it is 90 degrees. In the figure, ray KJ and KL are opposite rays. So KL and KJ opposite rays, which just means a straight line or a 180 degree angle or a straight angle. And KN, ray KN, bisects angle LKM, which means that it splits it in half, and we can show that by markings like this, okay, showing that those two angles are congruent. So in 9, if the measure of angle LKM is 7x minus 5, and the measure of angle NKM is 3x plus 9, find the measure of angle LKM. So we need some sort of equation here to solve for x, then we can substitute it back in here and figure out the measure of this angle. So NKM, let's talk about that. NKM would be half of LKN because KN bisects LKN, so it splits it in half. So this angle and this angle over here are congruent. So if we wanted to set up an equation and we have LKM is 7x minus 5, I wouldn't want to set it equal to NKM until I multiplied this angle by 2. So let's say that this angle is 50. So if this angle is 50, I would take 50 times 2, which would be this angle, which would be 100. Okay, so that's just an example. But anyways, I want to take NKM times 2. So NKM is 3x plus 9. So I'm taking 2 times 3x plus 9, and I'm setting it equal to LKM, 7x minus 5. So distribute. Subtract 6x from both sides. Add 5 to both sides. And x is 23. But a lot of times in geometry, that is not the answer that we're looking for. Like in this case, we're not asked to find x, we're asked to find the measure of angle LKM. So the measure of angle LKM, which is equal to 7x minus 5 If we substitute in 23 in place of x, we would get 156 degrees. Alright, on number 11, a miter cut is used to build picture frames with corners that meet at right angles. Part A, Jose miters the ends of some wood for a picture frame at congruent angles. What is the degree measure of his cut? Explain and classify the angle. So I'm not going to write it all out, I'm just going to talk about what it is here. So for our picture frame, we have a right angle, and his miter cut comes in right here, and it creates congruent angles. So this angle and this angle are congruent. So what is the degree measure of his cut? Well, I would just have to take 90 divided by 2. So each of those angles, here and here, is 45 degrees. So explain and classify the angle. So I've explained, and then to classify 45 degrees, that would be an acute angle. In part B, what does the joint represent in relation to the angle formed by the two pieces? So I've got my 90-degree angle here, and then my miter cut here. So this ray, the cut, represents the angle bisector, because this ray is splitting this angle into two congruent angles, and that's what an angle bisector is. In 12 through 29, use the figure at the right. Name the vertex of each angle, so where the two rays meet, the corner of the angle. So on number 13, angle 7. So angle 7, we were talking about this angle. Where are those two rays meeting? They're meeting at point P. So that is our vertex. Number 15, angle 1. What point are they coming to? They are coming to M. So vertex M. And the next part, name the sides of each angle. So it always, the sides will be two rays with an initial point where the ray starts, or the vertex of the angle, and then another point where the ray goes through. So on number 17, angle VNM. So our two rays, or our two sides of the angle, they would both start at N. So one of them would be NV, and then the other one would go through M, so NM. And notice the arrow direction. So it's starting at the initial point. It's starting at the vertex here and here. On number 19, we have angle 3. So for angle 3, my two sides, my vertex is R, and R is extending out this way, so I could call it RP, or I could call it RT. I'm going to call it RT. And my other side is extending out in this direction. Here I just have one point, so I'm going to call it RQ. In the next section, write another name for each angle. Number 21, angle QPT. So we're starting at Q, and then vertex P, and then T, QPT. So another name for this angle, we could reverse the order and call it TPQ. Let's just go with that answer. Number 23, angle 5. With vertex P. Okay, so there's some different options here, since we have 2 points on this side, N and M. So we could call this angle MPT or TPM, or we could call it NPT or TPN. All of those are possible answers. So I'll just go with the last one there, TPN. Number 25, name an angle with vertex Q that appears to be acute. So acute, we want it to be less than 90. So vertex Q, on this side, we would be measuring obtuse, greater than 90, but on this side here, so angle 4 would be a good answer. Number 27, name a point in the exterior of angle MRT. So we have the interior, everything inside, and then we have the exterior, everything on the outside. So any of the points out here is what it's asking for. There's a good one, point S. Number 29, name a pair of angles that share more than 1 point. Okay, so we could have adjacent angles. Adjacent angles share more than 1 point. So a good example of that would be this angle and this angle, because they share this side right here. They're adjacent. So on this side we would have angle MNV or VNM. And on the other side, VNQ or VNP, or you can go the other way, PNV or QNV. And that solves number 29. Copy the diagram shown, extend each ray, classify each angle as right, acute, or obtuse, then use a protractor to measure the angle to the nearest degree. Alright, so on 31, we'll start with EFK, angle EFK. Okay, so our key there is this box on the other side. So we have a straight line, which means that we have a linear pair. So on this side will also be 90 because it's 90 on that side. So 90 degrees, right angle. Number 33, EFH. So EFH, obviously less than 90, so acute. And it looks like FH is splitting this right angle in half, so half of 90 would be 45. Number 35, EFL. That's past 90, so that is obtuse. And it looks like these three angles are congruent, so 45 times 3 would be 135. Number 37, in the figure, ray BA and BC are opposite rays, so that's a straight line. BH bisects EBC, so this will split this angle in half into two congruent angles. Number 37, if ABE is 2x plus 7 and EBF is 4n minus 13, find ABE. So the key to this problem are these two marks, right here and here. That means that the angles are congruent. So if they're congruent, we can set their measures equal to each other. So the measure of angle ABE will be equal to the measure of angle EBF. So just substitute in the expressions, 2n plus 7 and 4n minus 13. So subtract 2n from both sides and add 13 to both sides. And divide both sides by 2. And then go back to the problem. Let's see what we ultimately had to find there. The measure of angle ABE. Which is 2n plus 7. So if we substitute in for n, we would get 20 plus 7 or 27 degrees. Number 41. Measure of angle ABF is 8s minus 6 and ABE is 2 times the quantity s plus 11. Find the measure of angle EBF. Alright, so ABF would consist of ABE and EBF, which we know are congruent. So basically, ABE, whatever this measure is, this measure will be as well. So if I want the entire angle, I could take this angle and multiply it by 2 to get the entire measure. So let's say that this angle is 40 degrees. So then this entire angle would be 2 times 40 or 80 degrees, something like that. So basically what I'm saying is the measure of angle ABF is equal to 2 times the measure of angle ABE. Okay, now that we have that written, we just substitute in. So 8s minus 6 and ABE, which is 2 parentheses s plus 11. And go ahead and solve. So we'll multiply here. And then distribute. And then subtract 4s from both sides. And we would add 6 to both sides. And then we would divide by 4. So S is equal to 12.5. Now we need to substitute in to find EBF. So EBF, we weren't given an expression for that, but EBF is congruent to ABE, which we were given an expression for. ABE right here. So EBF will be equal to ABE, which is 2 parentheses s plus 11. So substitute in 12.5. And we get 47 degrees.